Hello everyone, welcome to today's class. This is Teacher Simon taking you through IGCSE Core Mathematics paper 0580-32 for May June 2025, and this is part 1 for questions 1 to 12. Question 1, write 3:45 p.m. using the 24-hour clock. Of course, when we reach 12 p.m., then an hour that comes forth there, if it is in the 12 hours clock system, then we go to 1. You get it? Now there is 2, now 3. So if we get 3 and we add it on the 12, then we shall get 15, not so? So this will be 15, then 45. It is actually read as 15:45 hours. Okay. Then question 2, the diagram shows the square-based pyramid. So this is a square as the base, and then complete this statement. The pyramid has dash edges. So the edges, we look at the straight sides. Okay. These are the straight sides. Okay, straight side lengths, maybe, if I may say, side lengths would be better. So this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, 7, then 8. So we shall have our answer here as well, 8. And then vertices, we look at the corners. Okay, we shall say sharp corners. So there is this one here, that is 1, this is 2, this is 3, this is 4, and this is 5. So our answer is therefore 5 vertices. Question 3, convert 3 meters into millimeters. Now we know that 1 centimeter is equivalent to 10 what? Millimeters. Are we there? Then 1 meter is equivalent to 100 centimeters, not so? But each centimeter, remember, is equivalent to what? To 10 millimeters, not so? So meaning wherever there is a centimeter, I'm going to put this 10 millimeters. So put 10 here, that one will become now 100 times 10, which is 1000, not so? 1000 millimeters. You see that? Then how about now 3 meters? So 3 meters will be equal to 3 times 1000 millimeters, which becomes 3000. Then question number 4, apples cost $1.2 per kilogram and 1 banana costs 35 cents. And they are saying work out the total cost in dollars of 3 kilograms of apples and 7 bananas. Now we know that $1 is equivalent to 100 cents. Or in other words, 100 cents are equivalent to $1. You see that? So how about 35 cents? So this will be 35 times 1, then out of 100. So this one will be $0.35. Okay, $0.35. And then after that, we have the total cost. So the total cost here, remember it is in dollars. So we have to get the cost of the apples, then plus the cost of the 7 bananas, right? So we have 3, then times each kilogram of apple is costing 1.2. So this is 1.20, and then plus 7, but the cost of each banana is 35 cents, which is the same as 0.35. You see that? And then when we put this one in the calculator, we can get the whole answer right away. Okay, 3 into 1.2, then plus 7 into 0.35. This one then is going to give us 6.05. 6.05. Then part B, work out the change from $20. So the change is going to be, you get this $20, then minus the 6.05. So what do we get here? 20 minus 6.05. And we get our answer as 13.95. 13.95. Question 5. A student scores 58 out of 80 in a test. Calculate their percentage score. So the percentage score is going to be 58 here. Then you divide it by 80, then times 100. You put this in the calculator and you get your answer. 58 out of 80, then times 100, and that one becomes 72.5%. Don't round off this number. It is a terminating decimal, okay? Don't write 73. Yes, in an exam, we can round off and then we give you 73%, but you leave it here because it is what? A terminating decimal. Question 6, calculate 57% of 45. So this one will be 57 out of 100, then times the 45. 57 out of 100, then times 45. This one becomes 25.65. 25.65. And then question 7, a train leaves station A at 13:44. The train arrives at station B after 3 hours and 30 minutes. Work out the time the train arrives at station B as part A. So we shall have 13:44. Then we add 3 hours and 30 minutes. So when we add, this one will give us 44 plus 30, that is a 74, not so? 74, but it is already beyond the 60 minutes that go into an hour. So 74 minus 60, this one gives us a 14. That means here we'll write 14, and then I'll take that 1 hour up there, okay? So this will be 7, and then the 1, so that will be 17, okay? So that means the arrival time is going to be 17:14. And then here we have part B. The distance between station A and station B is 210 kilometers. Calculate the average speed of the train. Now, average speed is equal to, since it is kilometers per hour, this is distance out of time, not so? So total distance traveled, then divide by the total time taken. Now the total distance traveled is 210 kilometers. Total time taken is 3 hours and 30 minutes. So remember, time has to be in what? In hours. So I will say 3.5. Okay? Because 30 minutes is a half an hour. So it's 30 out of 60, that is a 0.5. So when I add it on the 3, then it becomes what? 3.5. So what do we get here? 210, then divide by 3.5. This one gives us 60. Question 8, the exchange rate is $1 is equivalent to 0.923 euros. And they're saying calculate the difference between 750 euros and $846. Give your answer in euros, correct to 2 decimal places. Now that means I need to convert the dollars to the euros, okay? All right, so if $1 is equivalent to 0.923 euros, that means $846 will be equal to 0.923 times 846. This one will give us 0.923 times 846. This one gives us 780, then 0.858. 780.858 euros. Then the difference is going to be, we just get the two and we subtract which one is bigger, is 780, right? It is this one that we have just gotten. So we subtract this 750. So what do we get here? The answer I have here, minus 750. That is 30.858. They want the answer to two decimal places. So we shall round off the 8 to this one and we put 1. So that one becomes 86, right? So it will be 30.86. That is two decimal places. As simple as that. Question 9. Flo has a bag of counters. She picks a counter at random from the bag. The probability that she picks a green counter is 0.52. Work out the probability that she does not pick a green counter. So probability of picking a green counter plus the probability of not picking it is always equal to 1 because total probability is 1. So that means probability of not picking a green counter is going to be 1 minus probability of picking a green counter, which is 0.52. And this one will give us 0.48. Then part B, the bag contains 3 colors of counters, green, pink, and red. We are given the probabilities in here. They are saying there are 3 times as many pink counters as red counters, okay? As many pink counters as red counters. What does this one mean? If the probability of picking red is X, then the probability of picking pink, let me write red in full, the probability of picking red is X, then the probability of picking pink shall be equal to 3x, okay? There are 3 times as many pink counters as red. So that means pink counters are 3 times the red counters, okay? Now we know that total probability is equal to 1. Total probability is equal to 1. So we shall have 0.52, which is given here, then plus x, then plus 3x. We equate to 1. So this one will be 4x here, which is equal to 1 minus 0.52. That one will give us 0.48. Not so? So meaning our x is going to be 0.48. Then we divide by 4, which is 0.12. You see that? Now, after that, we need to get now the value for... Now, this is the probability for picking red. So I'll write here, red is 0.12. Then for pink, it is 3 times. So you will have 0.36. As simple as that. And then part C, they are saying that Flo picks 1 counter from the bag at random, records the color and replaces it in the bag. She does this 200 times. And then it's a calculate the expected number of times she picks the green counter. So expectation or expected number of times is going to be equal to NP. So you get the number of times the experiment is done, then times the probability of picking, or the probability of your success. So the probability of picking the green counter is 0.52. Then what do you get? 200 times 0.52. And that is 104. 104. As simple as that. Question 10 is coming from circle properties and theorems. They're saying A, B, and C are points on a circle center or diameter AC. Complete these statements giving geometrical reasons. So the geometrical reasons we are giving are actually the circle properties and the theorems, okay? Then about A, the value of X is dash because of dash. Okay, when you look at this triangle here, AOB, you can see that this one here is a radius and this one here is also a radius, okay, from the center to the circumference, center to the circumference. Are we there? Then you can see that these sides that are the same, look at the sides which are opposite to them. I mean the angles that are opposite to them. Okay, so then these angles also are supposed to be the same if these sides are the same. Okay, so that means x has to be equal to 65 degrees. So my answer here, the reason is going to be base angles. Base angles of an isosceles triangle are equal. An isosceles. Mind about your spelling for isosceles. Isosceles triangle are equal. As simple as that. Then next, angle ABC is equal to 90. ABC, this one here, is equal to 90. Yes, it is true, because you can see SC is a diameter. Okay, so we shall say that angle in the semicircle, angle in the semicircle is always a right angle. Is always a right angle, or is always equal to 90 degrees, whatever you want. By the way, we also have another theorem here, that if I have this as the angle at the center, and then from this same point here and this one, we have these lines here, the chords that are coming from them to the circumference of the circle. So we can have this one here, then to this one here. This angle here, if it is x, then the one at the center is 2x. You see that? So when you look at this triangle here, the angle here is 180 degrees at the center. Then the angle at the circumference has to be equal to 90. Not so. So that is that. Then part C, the value of y is because, now, what do we have here? I can look at this triangle here. So that triangle, already this one is 90 degrees. And you know that angle sum of a triangle is what? 180. So that means this angle here and this 65 must give us another 90, such that when we add it on this 90, we get 180. Are we there? All right, so that means y is equal to 90 minus 65. So y is equal to 90 minus 65, or maybe we can say 180 minus, there is 90, then plus the 65. And this one will give us 25. 25 is the one you add onto the 65 to get a 90, right? So because we shall say that angle sum of a triangle, okay, angle sum of a triangle, or we can say angles, okay, angles in a triangle add up to 180 degrees. As simple as that. Question 11 is coming from bearings. The scale drawing shows the position of a hospital H. The scale is 1 centimeter, that represents 6 kilometers. Okay, that means we must measure something here, okay, because they have not put anything like not to scale. Actually, this one is to scale. This is the scale here. So whatever we are going to do on that diagram has to be in relation to the scale that is given. Then they are saying a school S is 33 kilometers from H on a bearing of 155. Mark the position of H on the scale drawing. Now, this is about bearings, so you should know that we measure bearings from the North Pole, and we go clockwise. We measure bearings from the North Pole clockwise. Now we need to find this one. We need to convert it to what? To centimeters. because what we are doing on this paper here, it is in centimeters. You cannot measure kilometers there. So 6 kilometers, we are given that they are equivalent to 1 centimeter. Therefore, 33 kilometers will be equal to 33 times 1, then out of 6 centimeters. This one will be 5.5 centimeters, because you can see you have 30 over 6, then plus 3 over 6. This is a half, and this is 5, not so? So that is 5.5. Now I'll come to this one here, and I'll get my protractor. After getting my protractor, I'll put it at this position H here. I'll make sure that this middle point here of this protractor is at H, and then we can rotate it, and we make this line here, the 0, coincide with the what? The North Pole. Okay, with that North Pole, and then after that we look for the angle. Which angle? The angle has to be 155. So our zero has to be this other side here, okay? Because we are going to move like this clockwise. So the 0, I can see it on the inner scale. Then I look for 155. So if I can zoom this one here, 155 is around here. You see this point here? It is here. So I mark that point there, and then let me take it back. It is going to be so small. That point that I've marked. So pull away the protractor, then now get your ruler, okay? And you put here on H, then you make sure that it passes through that point you have marked. So that will be the one there. And then from there, we have to measure off the 5.5 centimeters, okay? So I'll bring my ruler here, and then we shall place it here where H is. So I'll put my 0 there. Then we measure the 5.5 from there. Then if I can zoom well, you can actually see that 5.5 is here, not so? Is there. It is here. So now I can remove my ruler, and pardon me here. I can even take off the ruler and then the protractor. Then at that point, that is where we are having the S, okay? S. Then we can even rub this one off, and then we go up to there. So at that point, we know that this angle here is 155 degrees, and H to S is 33 kilometers, which is 5.5 centimeters. As simple as that. Okay. Question 12 is coming from statistics part A. Kim and Tom ask some students if they prefer chemistry, biology, or physics. Kim draws the bars for biology and physics on a bar chart, and these are the ones here. Then they are saying here that Tom draws the sector for chemistry in a pie chart that is 120. Okay, then they are saying use the information from both diagrams to complete the bar chart. Okay, now when I come to this pie chart, number of students who prefer chemistry, okay, we don't know them, and that is what we are going to use to do what? To draw. That is the one we are supposed to look out for. Okay, now number of students who do biology and physics. Okay, we can see for biology it is 9, and then for physics it is 7. So if we add them, that one will give us 16, right? So I'll have something here. Use the information from both diagrams to complete the bar chart. Okay, now for the bar chart, I have number of students number of students doing, we can say doing chemistry, or that prefer chemistry, okay, that are doing chemistry will be equal to, we have, when you check here, this is 120. Are we there? 120 degrees out of 360. Then times the total number, we don't know. You get it? But if I come here, in fact, let me just look at this one here. Let the total number of students, let the total number of students, because it wasn't given, total number of students be equal to x. Okay, so if it is equal to x, then we have for physics, physics plus biology, we have the 7 and the what? And the 9. We have the 9 here and the 7. So those are 16, not so? But for them, they are the ones that are going to occupy here. So this one is going to be 120 subtracted from 360. That will be 240, not so? So we shall have 240 or 360 minus 120 degrees divided by the 360, okay, of the total x. Are we there? Of the total x, then is equivalent to the 9 plus 6 we have gotten, 9 plus 7, which is what? 16. You get it? So this implies, if I can take this one down, this implies that you have 240 divided by 360 by 12, or by 120 you get 2, by 120 you get 3. So this is 2/3, okay? I'll write 2 over 3 of x, which is equal to what? 16. And then our x is going to be equal to 16 when you cross multiply times 3, then you divide by 2. This is 16 divided by 2, 8. Then 8 times 3, we get 24. So the total number of students is 24. Okay? So meaning the number of students who are doing chemistry will be 24, then minus this 9 plus 7, or minus the 16. Are we there? And this one will give us what? 8. So that means when I come this side, I'll draw my bar graph on 8. And this is the one here. As simple as that. If you want, you can shade this one, okay, to make it different from these ones here to show that you have done, but it is okay even to leave it unshaded. So you can have it like that. Then next, we are supposed to complete the pie chart. Now from here, we need to get the sector angle. Sector angle for physics. Remember, the number of students who are doing physics are 9. So we shall have 9 out of the total number of students, remember, is 24, then times 360, because in a circle the total angle sum is what? 360. And then next we have the sector angle for those doing what? Biology, right? So sector angle for biology, those doing biology are, by the way, biology is 9, then physics is what? 7. Pardon me here. So physics, I need to switch them here. This is biology. Biology is 9, physics is 7. 9 and then 7. So what do we get here and what do we get here? 7 out of 24, then times 360, that one is 105. Then this other one here will be, we put a 9 here, that will be 135. So when I come this side to complete the pie chart, I'll just draw one. Okay, I can draw 105, I can draw 135. So if I draw one, then the remaining one, of course, is automatically that one. Okay, so you get your protractor, and then you put it, the center of the protractor, you put it at the center of this circle here. Then I can rotate it this other side, and then I use this line here as my point of reference. Okay, then after that we measure. I think I'm going to measure 105, whichever you want, whether 135. Now, since I've coincided this with this line here, then my 0 has to be here, and then I measure this side. Okay, you can even bring your protractor here, and then you measure like this, whichever you want. Okay, so me, I've preferred this one here. So my 0 has to be this way. Okay, so I'm using the outer scale. So 105 will be here. You see this point here? So my 105 is here. So if I mark that point there, then I can put off my protractor here, and then you get your ruler, you connect the center here to that point which you drew. Now, based on mine here, the protractor was outside. Okay, the point was outside. So you need to take this one off, and what I measured here is 105 degrees. That means this one here is 135 degrees. Now 105 is for physics. So I'll put physics here, and then I'll put biology in this sector of 135 degrees. Okay, as simple as that. Then part B, give one advantage of reading results from a bar chart compared to a pie chart. Now, when you check these two, the bar chart gives frequencies, so you can easily see the number of students for this case. But when you come to this pie chart here, it just gives portions. Okay, so if it is 120 degrees, you can't know exactly how many students are in there. You get it? So I would say that the bar chart gives frequencies, whereas the pie chart gives proportions, as simple as that. So this has been it for this first part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful, kindly like, share, and even subscribe. See you in the next videos.